Welcome back to this third tutorial on data science projects, and in this tutorial we are going to look at something different, more of data science analysis for music. And the focus of this session will be to show you how you can use the concepts that we have learned so far in analyzing the popularity of a song, and therefore making informed decisions for those people who are into the entertainment industry on how they can leverage on some of the common properties of songs to understand how different people or the audience perceives the song, and thereby the popularity of the song. So the data is obtained for the last decades, and it contains several attributes of the songs. The data is segregated into each of the decades, starting with the 1950s, 1960s, 70s, 80s, 90s, 2000s, and 2010. It's a sample data set. It doesn't contain all the songs in the world. It's just a very few songs to help us drive the point home. So a quick look at the data set. They have similar columns. So we have got the title, which is the name of the song. We have got the artist who sang the song, and then the genre, different in different categories. Then we have got the year. This year is the planned year that they are planning to release the song, like kind of a remix, or maybe doing a remastering of the song. And then you have got the beats per minute. That one, you know how many beats in the song are there per minute. And then you have got the energy, abbreviated as NRGY. Basically, this is the energy of the song. The higher the value, the more the song is energetic. The dance, abbreviated here as DNCE, this is the danceability of the song. So it's basically how easier it is to dance to the song, and it rates from 0 to 100. So the higher the value, the more easier it is to dance the song. And then we have got the decibels. This is basically the loudness of the music. The higher the value, the more loud the song is. The next one is live. The higher the value, the more it is likely to be a live recording. And then we have got the valence. Valence is basically the more positive mood the songs gives to the listeners. And then you have got the duration in seconds. So this is the duration in seconds, how long the song takes to play. Then we have got the acousticness of the song, which is basically how the more acoustic the song is. So the higher the value, the more acoustic the song is. And then we have got the speechness, which is basically how much does the song contains the spoken words. And then this is the most important column, the popularity of the songs, rated from 1 to 100. So 99, 100, most popular song. 0, 1, 2, least popular song. So this is the brief description of the data set. This is just for 1950. The rest is the same until 2010. So this is what I want us to focus on, and we are going to formulate some potential business questions that you can answer with this data set. And as you notice, the data set comes in different files, so we need to find a way of aggregating all those files and then analyzing the data as a single data set. So without much further ado, let's begin with the usual ones. We'll start with importing the necessary libraries. So I'll be skipping the video or forwarding so that I type and we don't take much time on the video. So I'll be typing and then just copying them to ensure that we make maximum use of the short time we have, so that most of the video contains the technical aspect of it rather than the documentation of the code. So we start with importing the regular libraries. And the first library that I want us to import is the OS. This is to manage our files. And then we are going to import warnings. So this is basically to deal with any issues that might be arising from depreciated Jupyter notebooks or outdates that are in my Jupyter. And then we need to import Pandas as PD. This is for data science in Python. And then I can import matplotlib for plotting or visualization. So these are kind of the standard libraries that you import when you're working on data science projects, and then Seaborn as SNS. And yeah, so this should be enough. So as I said, the dataset contains several files, and we need to find a way of reading those files, combining them together into a single data frame so that we can work on it. So let me just document that. I've typed it somewhere else, so I'll just paste straight away to save us time on the documentation of that part. So to collect, this is what we have. We have got all this data set. We are working on this directory. So the idea is, let us collect each of these files, read them on our code, and then combine them together into a single data frame and then use them for analysis. So to do that, first of all, we need to obtain or know, if you watched my previous videos on working with operating systems in Python, you know that we can access the current folder where we are working on using the getcwd command in OS library, this library that we have imported here. So the first thing is to get the current. In other words, this is the folder where we are working on, current working. So make sure that you save the dataset in the folder that where you have saved your Jupyter notebook, so that you don't run into issues of missing file. The dataset has been provided in a link in the description, so please feel free to download the data before start working on it. And then we create a variable called CWD that contains the present working directory, and use the function getCWD, opening and closing bracket, to obtain the current working directory. So our current working directory, can print it using this to see, just for confirmation. So this is my current working directory. You can see I've created a folder called music to store all the files. And if you look at my directory, this is the folder called music. So in other words, we are safe. This is where our files are. So the next thing that we need to do is to find a way on how we can read each of those files. And before we read the files, let's create a variable called files that contain or list all those files in our folder, list dir cwd. So if I do this and print files, it will list all the files in the folder. It doesn't specify which ones. So these are all the files that are available in the folder. There's a Jupyter notebook pipeline. There are these different files, and there's this one that is kind of a hidden file in my directory. If you look at my directory, it contains each of these files that have been listed here. But we know for a fact that we are not concerned about these other files. We are only interested in the .csv files, because those are the ones that contain our data set. So we need to find an intelligent way of only reading files that contain our data. And if you can see from the look of things, all these files have got, they end in .csv. So in other words, if we can write a code that will only select files that end in .csv, then we should have all our data set read in Python. So that is the next big task. So to do that, we're going to write a loop. And the first thing that we can do before writing that loop is to create an empty data frame that is going to store all those files once we have merged them into a single data frame. And then the next thing we do is to iterate through. So we know that the variable called files contain all files in our present working directory, but we are interested in only files that end with the .csv. So the first thing we need to do is, first of all, just iterate through the directory to make sure that we are having all the files in our code. So we can say for file, by the name file can be anything. If you don't understand this, please refer to my previous videos on introduction to Python. So for file, in files, so this is just to iterate through the folder, and to make sure that it runs, we can do print file to see what's happening. Good, so you can see it's returning all the files inside the directory. Now the next task is to ensure that it only picks the files that ends with the .csv, and to do that we can take advantage of the inbuilt Python function called ends with. that will basically tell the user to tell the Python to only return files that ends with a particular string values. So .ends with is very, very important if you are into data science and data analytics, because you're going to use it most of the time. There's also its counterpart called starts with. So in other words, in Python, you can specify if a file starts with certain characters, then you select that file or delete that file or perform operation on that file. If it ends with certain characters, also you can do the same. So in this case, we are interested in files that end with .csv, and what we are interested in is to ensure that our code returns only the files that ends in .csv, as we know that those are the files that contain our data. So we can write that loop, say if this is the format, if file, so each of the file in the files, if file ends with the dot ends with, so that is how you apply it, ends with, and then inside the bracket you specify the characters that you are looking for, so as a string, so it is .csv. So if a file ends with .csv, so you can see any of these files ends with .csv, so it will only select the files that ends with .csv and avoid these other ones that ends with .ipynb. So this is it. Then what you want to do to that file is to create a data frame called a variable called df, which stores the data frame, and read that file using the pandas.readcsv command, not command but function. So read that file, and to show us that we are reading it, let's just print the first few lines of each of those files. So I can do df.head to ensure that it's doing exactly that, and read the first two. Let me just read the first two rows. So you can see it's doing exactly that. It is reading each of those files. So as you can see, there are 5 of them. So 1, 2, 3, not 5, 4, 5, 6, 7. So there are 7 files. So it has read all those files successfully. However, we don't just want to print them. We are interested in combining them into one. So we can use the append function to append them to this empty list that we created here. So let's do that using dfs. So we use the function called append in Python to allow us to, once we are reading each of these files, anytime we read the file, we append it to this empty list here to create a single data frame. So the function append accepts the individual data frames that you have read. So in this case, it's just the df. And then once we do that, now we can create a new data frame called df, and then merge each of these data frames that we have appended into the list together using the pandas.concat function that basically brings the files together. We learned that in our introductory to data science course. So we use the pd.concatenate function, and it accepts our list that contains several data frames that we have been writing, and then we ignore the individual index of the individual data frame that we have used in our case. So we do that, and then we can confirm by printing the shape of the data frame to see if we have got enough values. So this is not a tuple, so let's run it. Yes, so it has done successfully. You can see after combining the individual data frames, we only have 667 data points and 14 columns. So again, this is a small data set, is a sample. So it's not a huge data set, but it will be useful for the learning outcomes that we are interested here. So the next thing that we want to do is have an overview of the data. So let me write that to understand this data set. Data overview. So let me just write an introductory statement. Let us have an overview of the data set. So we do df. Let's start view the first few lines of the data set. So I will view the first 5 lines. So as you can see, it has imported each successfully. We have got the title, the artist, the top genre, year, BPN, and everything else that we need. For some reason, I just like having the columns so that in case I want to copy them, I can literally copy them straight away from my code. So I've just printed the columns, and we can define each of these columns, what they mean. So for your documentation, let me just write them somewhere and then paste them here so that you can use them in your as a documentation to guide you what each of the columns mean for future reference. So allow me to pause the video, type them somewhere, and then paste them here. Okay, now that I've done that, we can now dig into the business of the day, which is to, first of all, formulate the business question. So remember, I'm just formulating a business question for the learning purpose. But if you had this data set, probably you are working for someone or you are doing research, you will have got your already existing business or research question. So for the case of learning, I'm going to formulate 4 business questions, and then we are going to use the techniques that we have learned in the previous sessions to demonstrate that indeed we can answer those business questions through taking a deep look at the data set. Again, allow me to pause the video, but before I pause the video, let me take and write what we are doing here. And the business question, I'll post the video, write them elsewhere, and then just paste them here to avoid having more time dedicated to documentation rather than the coding. So these are the business questions. So the first question is, what was the most popular genre in each decade? What was the most listened to artist in each decade? What was the average danceability score of most recommended songs in every decade? So we are interested in, for the song that was popular in each decade, what was the danceability score? And once we know that, we can easily tell someone that, okay, if you're releasing a music, then you should be aiming for this danceability score so that it has a higher chance of being popular. And then the next thing will be, what was the average BPM score of the most recommended songs in every decade? So you look at the most popular songs in each decade, that is 10-year span, and look at the average BPM score. So once we know the BPM score, then the recording artist or the musician will understand that if I want my song to be more popular, chances are that my BPM should be within this range of values. So this is kind of giving insights or scientific insights to the producers of the songs to ensure that the artist in place is having his song popular, and thereby standing a high chance of generating more income in terms of online streaming. And then the last and very most important point from having this kind of data set is you can literally tell the secret behind a popular song on online streaming platform like Spotify or Apple Music or YouTube. So these are some of the questions that we are going to answer from this data set. Although it's a very small sample data set, I will challenge you to go out there, get more data set, try running this and see what the data is telling you. By that, you can easily raise or discover new patterns on how you can help somebody who is just an artist to apply data science skills to answer these crucial, pertinent business questions. So if you look at this data, there are some columns that we might not want to use. Something like the title of the song is not important because it's unique, so you don't expect to get any much from it. We have got the year that is going to be released or perform a remix or remastered. I don't think if we need that column, so I'm going to drop those two columns and remain with the rest. So to drop the column, let us drop unnecessary columns. So remember, these columns are only unnecessary for this kind of work that we are doing now. It might be super useful for other kind of work. So drop column, I'm going to create a new data frame df, and then drop column of the existing one using the drop function in Pandas, and specify the columns that I'm dropping as a list. So I'm going to pass them as a list. So I'm dropping the year and the title of the song, and then I'm going to set the axis to 1, and then confirm if I've literally dropped that song or those columns. So you can see I've dropped them. So now we are having only these columns remaining. Good. As you know, as is the custom, we are going to start performing data cleaning operations. So I'm going to create that as a new heading. It goes like this: data cleaning. So the first data cleaning operation is always to check for missing data points. So let us check for missing data points. I think this one also goes as data cleaning operation. So dropping the columns that we don't need, I think it goes as data cleaning operations. So I'm going to have them under that heading. Now, to check the data, if you have been following my tutorial, I'm going to create a list that contains all the column names, and then I'm going to iterate through those column names to check if each of those columns have got missing data. So I'm going to create a list called attributes that contains all the column names. So to do that, I'm just going to copy. This is why I was having this in mind. So I'm going to copy each of those columns and paste them into my list. So I have got a list that contains all the columns. And you remember, we dropped year and the title of the song. So I don't need those ones in my list. And then I'm going to iterate through this list and check if each of these columns have got any missing values. So to iterate that, I'll do for attribute. So for each of the columns in the list, for attribute in attributes, then create a variable called null check. So if you followed my previous data science project, you realize this is very common now. I use the pandas data function isNull function to check for the column. So I'm going to do df attribute and then basically print the null check to see if I'm having any missing values. Null check. So let me run this. If I run this, you can see that the first one, it returns so many missing values for top genre. So there's none, meaning that top genre has got several missing values. The other columns doesn't have got any missing values, so we are safe for now. Now we just need to figure out how to deal with these missing values. So in my previous examples, we have been using. So let me just document that for someone who might be interested in reusing this code. Let me document that. B. So top genre has got several missing values. Column has several missing values. So we can drop them. And remember, we only have got 667 data points. So if we drop any of this, it's gonna compromise the integrity of our data set. So we don't want to drop those columns. So remember, in our previous session, I always tell you that if you're handling missing data, there are several ways of dealing with missing data. One of the first ways to deal with missing data is basically drop the columns, and that is what we have been doing in most of our previous projects. The other way is always to use average for numerical values that are well distributed, something like temperature, rainfall amount, salaries, or something like that. You can use average to fill for the missing data. In other cases, you might want to use the common value or the mode of your data set. So if it's a categorical data set, you just want to use the mode to fill for the missing values. And that is what I want us to use today instead of dropping. Because if we drop our data set, we're going to run into trouble because we have got small data sets. So dropping more of them, it's going to compromise the integrity of the analytic that we are going to obtain from this data. So I'm going to just put a warning here so that somebody who is watching or using my documentation can take note of that. So allow me to write it somewhere and then just paste it here. So this is a small data set, and dropping some can hugely compromise the integrity of the analytical results. So let us use a different technique, as I said, and this time we are using the mode. So let's say, so we are going to use a different technique to fill the missing values. We fill any missing value with the most popular value corresponding in the corresponding column. So I will explain what this means. So let's come back to this data frame. So in other words, we realize that only top genre is missing some values. The others have got all the values. However, in the case of where we had several of these having missing values, then the code that I'm going to apply will be super useful. So what it does is it goes to each of the columns. Let's say top genre. If it finds our missing value here at row 1, then it will ask itself or compute the common value in this column called top genre and use that column value to fill that value here. If it comes to BPM and it finds that maybe row index 2 is missing, then what it does, it will check all the values in the BPM column and then calculate the most common one or the mode. And then if the mode maybe is 99, it's going to fill this missing one with 99. So that is the whole idea of what we are doing here. So it's a good technique for imputing missing data. So to do that, let us iterate through the columns, and then we're going to find the common value in each of the column. I'm just writing what I've explained, and then fill it where there is any missing value. So that is what I'm doing. So I will iterate through the columns. I will just say for column, and you obtain all columns using df.column, as you know that in df.columns. Then I'm going to calculate the mode value or the common value in each of the columns. So use the value column, and to calculate mode is just dot mode. Use the function dot mode, and then of course the first indexed one. And then once I've calculated the mode value, then I'm going to fill that missing value in each of the columns. So df.column. Then I'm going to use the function, the pandas function fill na to mean fill null values using the mode value that I've just calculated. So I'm going to fill that inside the bracket and replace everything, set in place to true. So once I run this, it will ensure that all the missing values, like in this case we had got missing values on the top genre that were missing, now they have been filled. So let's confirm. So let us confirm that all the missing values have been replaced. So we can confirm that by running our null check again. So let me just copy this code. But in this case, I don't want to run everything because we knew that all others don't have got missing values. The only one that has got missing value is the top genre. So that is the only one I'm going to include in my list. So I'm going to delete all these other ones and only include top genre to see if it still has got any missing value. So you can see it returns empty data frame, meaning that there's no missing value in that top genre. So we have successfully added or removed those values. So let me just comment that for purpose of documentation. We do not have any values, hence our loop worked successfully. I hope that's the spelling of successfully. So let us answer the business questions. Okay, so now that this has run successfully, we can start answering the business question, and I want us to list them as headings, each of those business questions. So the first business question was, what was the most important decade? The first business question. What was the most popular genre in each decade? So now it's interesting because the data set that we have doesn't have the decade information as stored in the data frame, but it is stored in the file name. So if you look at the file, each of those files are named by the decade. So 1950 basically is the decade 1950 to 1960. And then 1960 is the decade between 1960 and 1970. Then 1970 is the decade from 1970 to 1980, and like that until 2010. So the information, any data set that is inside here belongs to the 1950s decade. But in our data frame, it is not there. So how do we do that? So the best way to do it is to read this data frame and create an empty column that stores the decade information. So we're going to create a new empty column that will store the decade information. And then when we are reading the files, each of these files, what we are going to do is to look at the name. If the name is 1950, pick that 1950 and store it in the decade column. And then once we store it in the decade column, we now have that information. Go to 1960. When we are reading the 1960 file, we pick the information from the file name and store it in the decade column. So with that, we will keep track of the dataset that we are reading and the decade that it belongs to. So it's actually the same process as reading the multiple files. So the first thing I'm going to do is to just copy the initial here, the initial file here. And then I'm going to explain what I'm going to do to do that, to allow that to happen. So it's a super interesting challenge, but good for you. So I don't need to do list D because I've done that above. I only need to specify the empty column. And then let me create a list that stores the years or the decades. So we know it's 1950, 1960, 1970 until that. So let me create a list called years. So years. And these years, they are contained in the file name. So they are not integers, but they are actually strings. So 1950 here, although it's a number, but it's a string in this case because it's a file name. So let's have them as file name. So the first year is 1950. And I'm going to do that. I'm just going to copy, since there are 7 of them. And then the last one, of course. So the next one is 1960, 1970, 80, 90, 2000, and then the last one is 2010. Here is the challenge. If you can add 2020, please let me know in the comment section. So now we have got a list that contains the year names or the decade names as is in the file name. So now we're going to do the same process. Look for files in the folder. Check for only files that end with .csv. But now, before we do anything, we need to read the file. So we're going to read it as a data frame and then create an empty data frame called empty column called decade to store that information. So remember how to create data or empty column in data frame is just to use the name of the data frame, square brackets, and then specify the name that you want to use. So I'm going to use decade and then have and assign it to an empty string. So that is going to create a column that contains empty string. So that is it. In that you now have a data frame. We can run this so that you have a look of what's happening, what I mean by empty column. So I head to. So you can see we have got an empty column here called decade that doesn't have anything. So the whole idea now is to read every time we read the file, we check at the file name. If it contains any of these strings that is in our list, then that string will be inserted into the decade column. Good. So to do that, we are going to need to write a Python. We are going to write a loop here. So the loop will be check through each of these columns. So I can do for I in range. So remember this we did in our previous section. So the range, so we're going to iterate through each of the rows. So you can use the range function and then use the length of the data frame, which you can obtain using len, opening and closing bracket, inside it the data frame. So we are going to iterate through each of the index in the length of the data frame. So if I do len df, you're gonna know the length of the data frame. So it's 667, which corresponds to the number of data points. So in other words, I'm going to iterate through each of those data points, and what I'm doing while iterating through, I'm gonna also look at my list, check if 1950 is in the file name. So I'll do for year. So for each of the values inside my list called years, for year, in years. So if each of this value is in the file name, then I assign it to the decade. So for year in year, so for 1950, if 1950 is in the list, and then I'm gonna check if that year, so for each of these years in the list called years, if year is in the file name, so remember the file name is here, the file that ends with .csv. If year is in the file, that is, what do I need it to do? If that year, let's say 1950 is in the file name, then what I need to do is take that 1950 and have it or append it inside the decade or inside the decade column. So to do that, I do decade, the one that I've just created, and then specifically the data point. So that will be assigned the year that I've just iterated through. And then just like that, I can come back to my initial code here. Yeah. Append it to the empty list dfs dot append, and then the next thing that I'm gonna do is df equal to concatenate all of them using the concatenation function, and this accepts df, which is the list that contains multiple data frames. Then I will ignore their individual indexes to ensure that we have got a new set of index. And of course, I can print the first few columns to see if it has done that successfully. In other words, if the decade column has been populated successfully. So if I run this, you can see I'm having a list of warnings, but nevertheless it runs. So to suppress this warning, I can add the warning function here. In my libraries, I can say warnings dot filter warnings ignore. So it ignores any warnings like the ones I've just experienced. So this one should be a string. So let me run it again to see if I'm gonna have the warnings. It should suppress those warnings. The warnings are there, but it's just not displayed now. Yeah, so it has run without suppressing the warnings, and it has assigned each of the values here in the decade. So now that that is done, there's something interesting that you have to know about this value. Remember, we passed them as strings. So in other words, it's a number, but it is read as a string. And that is dangerous because we need numbers and not strings. If numbers are numbers, then they should be treated as numbers, not as strings. So I can do that. I can convert these numbers, or alternatively, let's first of all check to see if what I'm saying is true. So I can say, let me check the type of these numbers that we have to confirm if it's really a string. So I can write a loop for I in range, then len, just the same way, df. I want it to print the values here. So df in the column decade, specifically each of the values, so dot lock I, and all of this I'm just want to know the type. and run the code. So you can see it's a string. So that is dangerous because 1990 should be a value or should be an integer. So let's intentionally change that using. So let us confirm if the decade is an integer or a string using the following loop. Remember, we are not still answering the question, we are just treating the dataset in a format that it will allow us to answer the business question. So these are the normal challenges in a data science project. So it's not always applying what you know, it's always handling multiple problems before you can get to the final product. So as you can see, we have used this loop to check if that data is indeed an integer or a string, and we can see it's a string. So let us now convert it. Convert the string values to integers using the code below. So to convert that is very easy in Python. We just use the column of interest, which is decade, and then we assign it a new column. So we change the content of the initial column, that is string, and to do that we use as type. This will convert them or read them as strings, as integers. So do that. So we're gonna change contents of the decade and read them as integers, and then assign them to new data frame or new column decade, which is the same as the previous one, and then run this, and we can confirm. Let us confirm if the decades are now integers. So we can confirm that using the same script. Let me clear the results for this just for aesthetics. So run it again. Now you can see it's telling me that it's an integer now. It's not a string. So that is done. Well done. Let's proceed to answer the business question. Again, what is the first business question? What was the most popular genre in each decade? Before we do that, let us just check the genres available. Genres in our data sets. So we want to see what are some of the genre options. So to do that, we can use the pandas.unique function to allow us to check for any unique values in each of the column top genre. So we are interested in the column top genre, and then use the .unique function to check for all the unique values. In other words, we want to know which are the genres, all possible genres in this data set. So let's run this. You can see there are huge amount of genres. So there's lots of them. As you can see, this music was biased. It doesn't have got African music. Can't see it. So anyway, okay, there's Afropop. I don't know if that's African music. So we have got so many American music, so many British music, Canadian. So this was a sample. So please don't try to be political here. This was just for sampling, and it's for learning, not for politics. So my African brothers, please don't be agitated. It's just for sampling. Good. Now let's answer the business question. what was the most popular genre in each decade. We can easily do that by using the group by function. So what we are going to do is look at each decade. So each top genre, we look at the top genre column for each decade and look at the most common one. So common one would be mod in data science. So mod is the common. So let's use mod for each decade. So we're gonna we write a code that checks for top genre for each decade. So between 1990, what are the top genre, and then it returns that. It calculates the mod for that value. So we can easily do that using the group by function. So do group by. Although in words it looks complicated, but Pandas allows you to do it so easily. So we are interested in the decade column. And then we want to know the genre, so top genre. And then I want us to return it as an aggregate, so a set of numbers for each of those years, so aggregate. And then Pandas has got the mod function that allows you to perform mods for all the values in a Pandas series, like the data frame you have, so pd.series.mod. And this will tell us all the values if we run it. Yeah, key error, decade, so I've written it wrongly. I think it should be like that. So you can see it has returned this. It looks ugly. So let me do reset index, then name, and do genre. Good. So we have the decade and the genre. So 1950 adult standards was the most popular genre. 1960 same. 1970 to 1980 it was album rock. 1990s was dance pop until 2010. I'm interested or curious about 2020s. So please, if you have got that data, provide and we can extend our analysis. So we have answered that business question. We can easily tell that for every decade, this was the most popular genre. So for artists who are trying to record a song, maybe in 2020s, maybe chances are high that still the dance pop is the most popular. So you wanna try to move into that kind of genre of music to have international popularity, so to say. Business question 1 done. Let's go to business question 2. So the second business question was, let me just read it again. What was the most listened to artist in each decade? So same question, a different question, same structure. So let me just have it as a heading. So this should be question 2. What was the most listened to artist? So in each decade. So still, we're gonna do df group by. So first of all, we group it by decade. And then this time round is not the top genre, but the artist. So let me just copy the name, artist. And then I'm gonna do aggregate the results, but calculate the most common one using the mod. And then of course I can reset index name equal to artist. Let me run this and see the results I have. Good. So in the 1950s decade, Craig Douglas, Dean Martin, and the Fleetwoods were the best. or were the most popular artists in that year. 1960, the Beatles, very sound, very good music group. 1970s, Elton John. 1980s, Madonna. 1990s, Mariah Carey. 2000s, wow, Rihanna came into play. 2010s, Post Malone. Never heard of him. But anyway, that is what the data is showing us. So you can see we are able to return the most popular artist by each year. And this is very, very interesting for somebody who is interested in this kind of metric. So you can know, based on the kind of music they play, you can know that, okay, in this year, this was the most popular songs. And that kind of corresponds to what's happening in our previous data set. You can see 1970s, 1980s, the most popular song was album rock. And you can see the kind of musicians in those areas. They are kind of playing similar music. So it relates to what we are looking here. The third business question is, what was the average danceability score of the most recommended songs in each decade? So let me copy that. So there's the third business question. So different questions, same structure. So to do that, I can do, we are grouping by decade. But this time, we are using the danceability column. But this time I want us to pass more than one value. So first of all, let us count the number of columns in each decade, or the number of songs in each decade. And then we return the mean because we have been asked the average. So what is the average danceability score in each decade? Okay. Good. Wow. So in 1950s, people were not so much into dancing, just 73. 51, I mean. 1960, same, 51. 1970s, people really started dancing, 56. 1980, 62. Wow. It's increasing. 1990, 65. 2000s, this was the peak of dancing. And then 2010s, it kind of reduced. Maybe people started being more therapeutic with music. Technology is coming in. People prefer to listening to music rather than going out to dance. But still, it's a fairly big value for that case. So we have answered the first three questions. Business question, what was the most popular listen to artist? That is question 2. The first one was the most popular genre. And the last one was the disability score. You realize that to answer these business questions, even though they are very straightforward in terms of code implementation, we had to do lots of work to get our data into a shape that we can apply the technique that we are going to use to answer the business question. And that is what is common in data science. Normally, it's not about the end product, it's how you manipulate your way towards that end product. And that is why I'm always looking for this kind of data set that is not properly cleaned, it's not organized, so that you kind of have the gist of what goes into data science. So again, please, if you have not subscribed to the channel, do so. Subscribe. If you like the video, give it a thumbs up. Share with friends who are interested in this kind of analytics, and make sure that you stay tuned for the second part of this tutorial. So in the second part of the tutorial, we are going to answer the last two business questions. What was the average BPM score of the most recommended songs in every decade? And then the last one will be, what is the secret behind a popular song on an online streaming platform? I think by now you should be able to answer the fourth one, which is very, very straightforward. So please post your answer on the comment section and I will endeavor to read it. Until the next part of the video, bye-bye.